I have worked with hundreds of customers helping them to build enterprise scale applications. And the question that often comes up is which Azure service is best to run my enterprise applications? This question is very common among technical decision makers, architects, and technical leaders. Just the other day, we were in deep discussion on which container platform is better. And somebody said it must be decided based on the ecosystem. Others said different things to be considered. There is a better question to ask when you want to decide the right platform for your applications. Well, I'm not going to reveal the right question just yet, but we promise you that it'll be obvious as we continue to talk.
Like Asir, I help our large enterprise customers build innovative applications that drive business value. 4 years back, I was working with this Fortune 100 company as a trusted Azure advisor. And you know what? Their enterprise architects literally took 3 years trying to figure out the container platform that they can use to run all their applications. And I suspect they are still working on it. They were evaluating 2 to 3 container platforms, and they want to arrive at this one platform that they can use to host all their enterprise applications. In the meantime, they were holding up several of their application teams who were eager to modernize their applications.
And while they were thinking through this, Microsoft deprecated Azure Container Services and introduced Azure Container Apps. Now, searching for a one platform for all thinking is what we refer to as ARB thinking. Many think they must just have one platform for all applications. For example, do I use Azure Kubernetes Service or Azure Spring Apps or Azure Container Apps for all my container-based applications?
If you have been working with Azure for any period, you might have grappled with the same question. Which Azure service is best to run my apps on? This is an important question because the services you choose will dictate your resource planning, your budget, your timelines, and ultimately your time to market. It impacts the cost not only of your initial delivery, but also the ongoing maintenance of your applications. This question can be confusing because Azure has a ton of services that you can leverage to run your applications on.
Traditionally, organizations have thought that they must choose between two platforms, two technologies, or two competing solutions to build and run their software applications. For example, they ask questions like, do we use WebLogic or WebSphere for hosting Java enterprise applications? Should Docker Swarm be the enterprise-wide container platform or Kubernetes? Or do we adopt containers or just stick with virtual machines? They try to fit all their applications on platform A or B.
So, having worked with many enterprise customers, a consistent theme that we have observed is a struggle to pick one Azure service to host all their enterprise applications. In the on-prem world before the cloud, ARB thinking made sense because of reasons like resource optimization. For example, it didn't make sense to have two ERP systems because it takes a long time to set these up. You got to procure the hardware, configure networking, and then install and configure software. Same with application servers. It simply didn't make sense to maintain multiple application hosting platforms.
There are other reasons like external players, like vendors trying to push their products and agenda, compliance requirements, internal politics, job preservation, that contributed to ARB mindset. But the key drivers are significant upfront investments and long lead times.
As you move to the cloud, you realize that you don't have the same constraints as the on-prem. Cloud provider now assumes many of the responsibilities. Cloud is on demand and elastic with no upfront costs. You only pay for what you use.
Cloud operates in an as-a-service model. You can provision or deprovision infrastructure and platform services at your will. For example, you can spin up and destroy an Azure Kubernetes service cluster with hundreds of virtual machines in a matter of minutes. Similarly, you can spin up and destroy any other service instance. This means you can use Azure Kubernetes service for one application and Azure Spring Apps for another application without any overhead like you have for on-premises systems.
The cloud sets you free and makes it easy to adopt a new model, the A plus B model. A plus B simply means that you choose the Azure service that solves your use case the best. You use the right tool for the right job.
A plus B approach has several advantages. In the ARB approach, more often than not, you decide on the solution first and force fit the use case to solution because there's only one platform and usually one team supports it. The platform becomes too big and the platform team is too small, which leads to bottlenecks everywhere.
On the other hand, the A plus B approach enables you to choose the right tool for the right job based on your use case. You don't have to spend all those hours working with the centralized teams trying to fit your use case to a predetermined solution. You can be more agile and you will have greater process efficiencies because you are more independent now. You can now innovate and go to market faster.
So, what are the current industry trends? Are any companies adopting the A plus B mindset? Yes, they are. Many organizations say they are willing to use more than one service. A plus B mindset. For example, take Barracuda. Barracuda is using many Azure services across their applications based on what they need. Andy Blyler, who is the vice president of engineering at Barracuda, says if an Azure service can perform or augment a function they need, they use it.
We notice that many of our customers struggle to choose the right Azure services for their applications, not because they're not smart or don't know what they're doing, but because of the old ARB mindset. We would like to introduce a few simple and practical principles that you can use to transition to the A plus B mindset. The first principle is you go from use case to the solution, not the other way around. You start with your business requirements.
Then you understand your business goals, your competition, and how often you need to change your product features to meet the market demand. You also understand non-functional requirements like security and compliance requirements. Finally, this is often not considered. You want to make sure you have a good idea of your budget and timelines. Then you want to make sure you are using modern development practices like DevOps and GitOps and using cloud native services as much as you can because they accelerate your developer velocity and time to market by a great extent. And they will also help you stay lean and agile all the way. And finally, based on the analysis we talked about, you choose the Azure service that best meets your business and non-functional requirements. These principles, they sound very simple and intuitive, yet we can't tell you how many people that start with the solution first and then back with the requirements.
So what is the scope of A plus B mindset? Where can we apply it? A plus B mindset applies to any application written in any programming language. A plus B approach applies to any cloud service across any cloud provider, though today we are focusing on Azure services. Now that we have introduced the principles of A plus B, We are going to illustrate the A plus B approach using Azure Spring Apps and Azure Kubernetes Service. However, like we already said, you can use this approach to evaluate any set of Azure services. For example, Azure Container Apps versus Azure Spring Apps, or you can evaluate Azure Functions versus Azure App Service.
Let's see how many real-world deployments look like with the A plus B mindset. Bosch is a world-renowned manufacturer and a leader in IoT solutions. Bosch developed an IoT solution called Track and Trace that provides real-time information on the load status of shipping assets, such as load carriers, truck trailers, semi-trailers, locomotives, railroad cars, and ocean freight containers. Track and Trace was originally developed and deployed on premises, but was later modernized and migrated to Azure. Now let us see how we can apply the A plus B methodology to choose the right Azure services for this application. The first principle, as we know, is to start with requirements. There are some very specific requirements for Track and Trace. First, the team already has an application that consists of several Java-based microservices. So, they want a platform that supports both Java and microservices-based application deployments. Secondly, the team that owns this application has no desire to manage infrastructure, and they have no in-house Azure Kubernetes service expertise. Security and monitoring are table stakes for this application. Track and Trace expects to grow rapidly, so high scalability is a non-negotiable requirement. Finally, the team wants to focus on product development, so they want as little build and deployment overhead as possible.
We will consider two Azure services that could be a potential fit for hosting the Track and Trace application and evaluate them against the requirements. You can deploy highly scalable and resilient container-based business-critical applications on AKS. Kubernetes ecosystem is built just for that. Since it is a container-based platform, you can containerize and deploy apps written in any programming language. You can also deploy sophisticated microservices architectures on AKS. AKS also provides you the security controls so that you can secure your application end-to-end. However, the power and the flexibility AKS offers also requires a deeper level of subject matter expertise in AKS. It requires a steep learning curve and quite a bit of infrastructure management. Ideally, you will need a team that is dedicated to AKS configuration, deployment, and management. As we know, the Track and Trace team has no desire to learn AKS or manage infrastructure. This makes AKS a less desirable solution for this use case.
On the other hand, like Azure Spring Apps also supports running world-class business-critical microservice-based Java applications. Because it's a platform service, no infra management is necessary. It comes with comprehensive monitoring capabilities that can easily be enabled. It also makes your automation, CI/CD process much more lightweight, reducing your deployment and management overhead to a greater extent. Since there is no complex infrastructure management, it has a much shorter learning curve. So for this use case, Azure Spring Apps is a better choice. Azure Spring Apps meets the business requirements, supports rapid implementation and deployment as the Track and Trace team wanted. It reduces operation overhead and supports DevOps and automation.
Here is a quick review of the actual design that the Bosch team used to implement Track and Trace in Azure. This is a very simple architecture. They used Azure Spring Apps as their core application platform to deploy their microservices, along with other Azure services like Azure SQL DB for the database, Azure Application Gateway as a layer 7 load balancer, and then you also see that they used Power BI for reporting.
Residential IoT Services, RIoT, is a startup created by Bosch. RIoT built a smart home platform called RIoT Platform that provides back-end services for the Home Connect Plus app that home users to connect, automate, and centrally control various smart home devices from a single user interface. It's an instant hit. The Home Connect Plus service attracted a large number of users in its very first month.
To meet the anticipated scale of service, RIoT engineers made an early decision to use Azure along with Dapper, an open source framework that makes it easy to build microservices for the cloud and the edge. However, they needed to choose the right Azure service to run their applications on. As you can see, the key requirement here is the service should support running Dapper-based applications. In addition to that, given the nature of business, the application must support large number of concurrent users, must support scaling out individual components without scaling the entire application. Also, the dev team prefers an abstraction layer instead of directly dealing with Azure. Finally, high availability is non-negotiable.
Today, we are only considering Azure Kubernetes Service and Azure Spring Apps for the A plus B analysis. However, you can apply the same methodology to any number of Azure services that are potential platforms. Let's run the key requirements against the two services to find out which one is a better fit. Azure Spring Apps supports deploying highly available applications which can be scaled independently. However, it does not support Dapper-based applications today. Since the application team decided on Dapper as their application framework, Azure Spring Apps is not the best fit for this use case.
On the other hand, AKS, while supporting high application availability and component level scalability, it also supports deployment of Dapper-based applications. Dapper can run as a separate sidecar process, providing the abstraction layer to the application. So in this use case, AKS is the right solution. AKS meets the business requirements, security and compliance requirements, and it enables automation and DevOps, thus meeting the key A plus B criteria.
Here's the high-level architecture for the solution that Bosch team implemented. Azure Kubernetes Service is the core application platform that's running the application code as well as Dapper. If you notice the application, it also leverages many Azure platform services in addition to Azure Kubernetes Service. Just like the track and trace application workload, App Gateway is used as the application delivery controller here as well.
The Kroger in-stock application makes it easy for the store personnel to locate inventory, and this was crucial to providing exceptional customer service. The in-stock application was number one application in terms of business impact in 2019, significantly impacting the revenues in terms of recovered lost sales. The in-stock application that was running on-premises on Pivotal Cloud Foundry hosted on VMs had scale challenges. They wanted to scale the application to support several more stores than the on-premises solution could support.
To scale the solution from 150 to 2,500 stores, Kroger decided to migrate the in-stock application to Azure. They want an application platform that can scale seamlessly as they added more and more stores and more services. The other challenge is production, cutting over from production to production kind of migration. As Kroger put it, they would like changing not just the tires, but the whole engine of the race car at a pit stop. So having a monitoring dashboard to understand the health of migration is pretty crucial. Finally, they needed secure access to on-prem databases because some of the databases will be on-premise after migrating these applications to Azure.
Like other case studies, here also the potential platforms are AKS and Azure Spring Apps. In this instance, both Azure Spring Apps and Azure Kubernetes Service meet the core requirements of dynamic scalability and hybrid connectivity to on-prem databases. However, since the application is built on Pivotal Cloud Foundry, which is based on Spring Framework, Azure Spring Apps is a better natural fit because Azure Spring Apps is Spring aware and it takes care of the Spring Framework related configurations automatically.
So Azure Spring Apps is a better fit here. It meets the business requirements, supports dynamic scaling and end-to-end monitoring, enables automation, and supports DevOps. Kroger has built a solution using a range of Azure services, including Azure Spring Apps, Azure SQL Database, Azure Cosmos DB, and Azure Functions for real-time computations, involving architecting 25 services and 29 databases. Azure Spring Apps runs in Kroger's private network, and secrets are stored in Azure Key Vault for a zero trust security approach. The solution is highly available, fully automated, and includes end-to-end monitoring. It's also a true hybrid deployment, with each store functioning as a mini data center that connects to Azure. Apps on Azure connect to APIs from Kroger's data center.
By moving to Azure, Kroger increased active store capacity from 300 stores to more than 2,500. InStock is currently being rolled out across Kroger's locations, helping delight customers by ensuring that the products they want are available in their local stores at the right time.
AIA Singapore is a subsidiary of AIA Group Limited, a leader in life insurance and financial services with branches and subsidiaries across 18 Asia Pacific markets. AIA has several Java as well as some .NET applications that are running on servers on premises. To account for unexpected spikes in traffic, they had to over-provision their on-premises hardware, incurring significant cost overhead. They wanted to migrate to the cloud to achieve more cost efficiency, performance enhancement, and the ability to accelerate the delivery of new and innovative solutions to their customers.
AIA Singapore had several Java applications, including their flagship iPOS application. And these applications were hosted on-prem on application servers like JBoss EAP. They also had a few .NET applications. They over-provisioned their servers on-prem to account for unexpected spikes in the traffic. As you know, over-provisioning servers just to meet sporadic spikes in traffic is not the most cost-effective solution. So AIA was looking to Azure to gain both cost and performance optimization. In addition to that, AIA wanted to have a cloud platform that not only enables them to modernize their existing applications, but also rapidly build new cloud-native applications. They have 9 to 12 months to their first production workload, and they have the skills to build, configure, and manage AKS clusters.
Let's consider two services. AKS supports on-demand scaling, so there is no need to pre-provision servers like they were doing on-premise. By moving to on-demand scaling, they achieve cost efficiencies and meet their performance and scalability requirements. Azure Kubernetes Services language agnostic platform for running container-based applications. So they can run both Java and .NET applications using the same platform. The same platform can be used for modernizing their applications as well as building new cloud-native applications. Once the initial infrastructure has code pipelines to automate the build and configuration of Azure Kubernetes clusters are put in place, new applications can be rapidly deployed to Azure Kubernetes Service clusters.
Azure Spring Apps also provides all the capabilities of AKS, except that It is an opinionated framework for running Java Spring applications. Since AIA has some non-Java applications and they have the skills in-house to manage container development lifecycle as well as AKS clusters, Azure Kubernetes Service is the right choice here.
AIA team chose AKS as their platform of choice, and they had an early success by migrating IPOS, a mission-critical application, to Azure Kubernetes Service. In terms of the high-level architecture, AIA deployed cross-region active-passive Azure Kubernetes clusters using their Java apps running on Apache Tomcat application service. They used a hub-and-spoke model for networking and implemented a zero-trust model which locks down resources from both inside and outside of the network. The core principle of zero trust is to maintain strict access control. It's deny all until verified approach. To implement zero trust on Azure, AIA Singapore took a layered approach to corporate and customer data security, centered strongly on user identity. They enforce least privilege, giving users only the access they need.
Along with AKS, AIA used other PaaS services to implement the complete solution. For example, Azure SQL Database and Azure Blob Storage for the data layer, Azure Service Bus for messaging, Key Vault for certificates and secrets, and Azure API Management as their API gateway.
A lot of us have seen a tracking dashboard while expecting our delivery. At a time when the global supply chain has been impacted, ensuring that their customers receive their packages within established estimated time of arrivals is at the heart of FedEx logistics system. As a customer, we get to see our own dashboard, but FedEx deals with a massive volume. And to deal with this volume, FedEx launched a Java-based solution running on Azure, a global delivery prediction platform. The platform dynamically predicts estimated time of arrival for more than 16 million shipments a day. It does this more than 10 times a day for each package. This calculation is powered by over 800 million events per day.
Now you can imagine the scale involved here and see that the applications have a huge impact on customers with time-sensitive deliveries. Given the volume of shipments, all parts of the application need to operate at cloud scale with high availability and reliability. These are new applications and they like to advance to production faster and rapidly release iterations. Ease of use is important to FedEx. They like their teams to focus on the business applications, not on the underlying infrastructure or monitoring. Autoscale is another requirement to handle unpredictable volumes of shipments. Their prediction systems depend on many other backing services, particularly eventing, ML, and Redis cache. So they are looking for ready-to-go integrations with Azure services. And finally, security and monitoring are table stakes.
We will consider two Azure services that could be a potential fit for hosting the global delivery prediction platform applications and evaluate them against the requirements. You can deploy highly scalable, resilient, and available applications on Azure Kubernetes Service. You can deploy any app on Azure Kubernetes Service. FedEx is looking for high application availability and auto scale to handle unpredictable volumes of shipments. This means they must build the application availability on top of infrastructure, virtual machine storage, network availabilities, and Kubernetes API server availability. The power and flexibility Azure Kubernetes Service affords also requires a deeper level of subject matter expertise in Kubernetes. That's a steep learning curve, and it does require quite a bit of infrastructure management. Also, Azure Kubernetes Service requires a source to container image strategy that can be always up to date as operating system, operating system dependency updates, JDK updates, and APM agent updates are continuously available, which often results in updating your container images on a weekly basis. They must instrument their apps using application performance monitoring tools as part of your source to container image strategy. They also need a platform engineering team that is skilled in Kubernetes. These make Azure Kubernetes Service a less desirable destination for these requirements.
Azure Spring App supports running mission-critical Spring and Java applications at cloud scale. Out of the box, it supports application availability, monitoring, and autoscale. You can configure autoscale to meet your business baseline and unpredictable volumes. Since there is no complicated infrastructure management, and you do not need any source to container image strategy and implementation, and the service will make sure that your apps are always up to date, it reduces plenty of operational toil and lets you focus on business, not the underlying infrastructure or source to container image strategies. The service also matches FedEx requirements to focus on business applications. And Azure Spring Apps meets their requirements to advance to production faster and rapidly release iterations. So for this use case, Azure Spring Apps is a better choice.
Here's a quick review of the actual design that the FedEx team used to implement their global delivery prediction platform on Azure. Azure Spring Apps is the primary compute for processing high-volume messages for FedEx prediction platform. FedEx chose Azure Spring Apps because of its ease of use and auto-scaling capabilities and the fact that it is a fully managed service. The tight integration with other Azure services also enable FedEx to move quickly with confidence in building and delivering the application as part of their worldwide web presence. You can also see how the team took advantage of many Azure platform services, right tools for the right jobs. This is an example of how you can build globally available digital experiences where you can focus on your application and depend on the platform for reliability, scale, and meet your business requirements.
FedEx picks up and delivers millions of packages going to thousands of customers. And it all has to be planned. And it is a very complex operation. You have to do several route optimizations and sequencing, which is vital for getting the packages to the customers when they need them.
FedEx Star is an effort to modernize their pickup and delivery operations. The challenge that they were trying to solve was scalability. Traditionally, they had a very static infrastructure. It was not able to scale up or scale down. So they would have that infrastructure consuming cost when they were not putting any workload on it. They had to have a system that was flexible and could expand and grow as their company does. That's where they looked at Azure. Everything they worked on is mainly Java. They want to leverage their existing Java practice to act as a bridge between on-premises and Azure. They do not want to build from scratch, but simply plug in the existing Java libraries. They built Spring Apps that pulls off an event-driven messaging queue, then integrates with Azure File Share and Storage Queue to trigger C applications. They have a preference to use Kubernetes event-driven architecture for scaling C applications and scale it out based on messages. And they wanted to go to production in 6 months.
We will consider 2 Azure services that could be a potential fit for hosting these apps and evaluate them against the requirements. Azure Spring App supports running mission-critical Spring and Java applications at cloud scale. However, in 2021, Azure Spring Apps did not support C apps or container apps. Plus, FedEx wanted to take advantage of the Kubernetes event-driven architecture for scaling out their C apps based on messages. FedEx team also has the platform expertise and the governance in place for operating AKS. So FedEx chose AKS for hosting C applications. However, for Spring Apps, they continue to use Azure Spring Apps. Out of the box, it supports app availability, scalability, monitoring, and auto scale. This way, they can focus on their apps without having to worry about the underlying infrastructure. This is a great example of applying the A plus B mindset to choose the right tool for the right job.
When you use the right tool for the right job, you can go fast. As Sunil says, they were able to start from nothing to end product within 6 months. That's pretty fast. And they can scale within minutes to process hundreds of requests, also scale into reduce cost. You can see the actual design FedEx team used to modernize their route planning for pickup and delivery operations.
Quickly walking through some more examples, Digital Realty chose Azure Spring Apps for their customer-facing global portal and APIs.
JB Hunt, they migrated their 80 plus Java apps backed by mainframe databases to Azure Kubernetes Service. They built a new marketplace feature for JB Hunt 360. They are using this to seamlessly connect shippers with carriers, matching the right loads with the right trucks.
If you remember, at the beginning of this talk, we hinted that there is a better question to ask. And now you know it. Ask not which Azure service is better, but which Azure service solves my use case the best.
We built a framework to deeply think through this. Ajay and I captured the framework and how to practically apply it in a short book. Please read the book. It's very simple to read. You can read and apply the principles of A plus B mindset to build better applications faster. The book is free for you and free for everyone. We would love for you to share what you learned today with your teams. Use this as a conversation starter or simply an excuse to have that conversation. Please read the book and share it. Again, it's very simple to read. You can read and apply the principles of A plus B mindset to build better applications faster.